Hi everyone, this is the 2.2 video called Linear Relations and Functions, and we are going to discuss what criteria have to be met in order for a function to be considered to be linear, and then actually work with some functions as far as looking at what we call their standard form in different parts of the function. So a function is considered to be linear if there are certain criteria that are met. First, graphically, the graph is a line. There's no curve to it. It's completely straight, and that's what constitutes a linear function graphically. It has, when it's written out in its either slope-intercept form or its standard form, it has a maximum power or exponent of 1 on the variables that are dealt with in the function. And it also fits either the y equals mx plus b form, which we all know as slope-intercept form, or the ax plus by equals c form, which we know as standard form. We're going to go through both of these forms, y equals mx plus b and ax plus by equals c, a little bit more in depth. But you've seen them in Algebra 1, and that's why it was okay to mention them in this situation. So make sure that you have this criteria down in your notes so that if I ask you whether something is a function or not, and it's a linear function, then you'll be able to identify it. I'm going to move to the next screen. If I can get my mouse to work here. And just go through 3 examples that deal with testing out whether we have a linear function or not. I'm going to ask you to support your choice. So on any assessment or in any homework assignment, I want to know why you decided that something would be linear or considered to be nonlinear if it's not. So the first one is f of x equals 8 minus 3/4 x. Look at that and make a decision on whether that would be considered to be a linear function. Does it meet the criteria that I had on the first slide in order to fit the linear function idea? Does it have, graphically, is it a line? Does it have a maximum power of 1 on the variables? And could we put it in the form y equals mx plus b or the standard form ax plus by equals c? Now remember, f of x means y. So this is the same as y equals 8 minus 3/4 x. The powers on the variables here are each imaginary ones, so it fits that criteria. And if we really rearrange this, we can put this in y equals negative 3/4 x plus 8 form, which is our slope-intercept form. So we can check this off and say, yes, this is a function. B, which is f of x equals 2 over x, is this considered to be a linear function? Well, let's look at the 2 over x part. The 2 over x piece implies that having this variable in the denominator has got a power of 1. But if we move it up to the numerator, like we would want to kind of model the y equals mx plus b form, you notice that the variable's in the numerator in this would be like an over 1. If we bring this x right here up to the numerator, we're going to end up with f of x equals 2x to the negative first. And because of this power of negative 1 on the variable, we're going to say that this is not a linear function. It's a different type of a function. It's called a rational function, and we'll study that a little bit later in your years of math, really in pre-calculus. The last one, g of xy is equal to 3xy minus 4. Now looking at this, one thing is really strange to begin with. We've got this kind of coordinate pair on the left-hand side with our function notation. And on the right-hand side, we have these variables being multiplied together. The fact that both of them have powers of 1 meets the idea of a linear function, but no variable combination can be multiplied together. They can be added or subtracted, but they can't be multiplied or really divided. So we would say, because of the multiplication situation here, that this also would not be considered to be a linear function. You'll have to, when you do your problem set and when you do some work for me on an assessment, you'll have to be able to identify if something is considered to be linear or not. So you should review those criteria and come in and ask me if you have any questions. Moving on, let's try this problem. A little bit more of a real-world application type thing. It says the growth rate of a sample of Bermuda grass, which is a special kind of grass, you might even want to research it and find out what it is given by f of x equals 5.9x plus 3.25. This is considered to be linear. We've got powers of 1 on our variable. Remember, this is y, like y to the first, where f of x is the total height in inches, x days after an initial measurement. We want to know how tall the grass is after 3 days and then deal with something else in part B. So let's focus on the first part initially. How tall is the grass after 3 days? Well, the 3 days deals with the variable x. So because this was presented to us in function notation, f of x equals 5.9x plus 3.25, excuse me, we can sub the value of 3 in for x and evaluate f of 3. When we do that, our work is going to look like this: 5.9 multiplied by 3 plus 3.25. And that's going to give us a total answer of, if we multiply 5.9 times 3, we're going to get, what, 17.7 plus 3.25, which is going to give us 20.95. Now, in an application problem, I'm expecting some type of label. F of x, which is our range value, that's our y value, deals with the total height, and we're told in inches. So we've got to put an inch label on this. So after 3 days, that grass is 20.95 inches. That's pretty high, I would say. Pretty fast growth rate. In part B, it says the term 3.25 represents the height when the grass was initially measured. The sample is how many times as tall after 3 days. So how much bigger is this value? How many times bigger is this value than that value? How would you figure something like that out? What does that word times imply? What operation in math? If you're thinking multiplication, you're 100% right. So what would we multiply 3.25 to get to 20.95? In order to figure that out, we can actually turn this into division and get an approximate. Actually, if you do this on your calculator, you get a decimal answer. So I'm going to do a squiggly equal sign for approximately. 6.446 times as tall. So that tells us that it grew 6.4 times in 3 days, which, again, like I said, is a pretty fast rate of change over a short period of time. Think about this. Let me know again if it doesn't make any sense to you and we need to go through something in class. Write that down as a question if you have it in your notebook. We're almost done with this section, believe it or not. It's not too much longer. The next idea that we have to deal with is called standard form. And standard form is that form that I mentioned earlier at the beginning of the video. That's the form where the variables are both on the left-hand side. So our linear function fits the form ax plus by equals c. Now there are a couple conditions that have to be met here. A, b, and c are all integers, which means they're not fractions. A has to be greater than or equal to 0, so it's got to be, A is a whole number then. And we also have to say that A and B are not both 0. What would happen if A and B were both 0? Hopefully you're thinking that if A and B were both 0, that would make the x go away and it would make the y go away, and we would just have c left. So we wouldn't have any type of even an equation at all. We wouldn't have a function to work with at all. So A and B can't both be 0. So our job strictly with this type of situation is to be able to write something that may not be presented to us in standard form initially in standard form. So we have this function, linear function, f of x, no, it's not f of x, sorry, negative 3/10 x equals 8y minus 15. And I want to put that into standard form and then identify the values of a, b, and c. So if we start off with negative 3/10 x equals 8y minus 15, our key here is because these all have to be integers, we can't have any fractions. So the 10 that's in the denominator right here is causing us a little bit of a problem. We also know that a has to be greater than or equal to 0, which means either 0 or positive. Now the value for a, which is attached to the x, you notice in this formula up here, right now in our problem is negative. So to get rid of, quote unquote, get rid of the 10 in the denominator and the negative sign, I'm going to multiply both sides by negative 10. So I've got to multiply the left side and the right side. And what that's going to do is give me 3x equals negative 80y plus 150. We're almost in our standard form. Standard form, you notice, has the x and the y on the same side. So I've got to add 80y over to the left side and end up with 3x plus 80y equals 150. Sorry. Whoops, this is a big eraser. So equals 150. I think this was a plus. So this is our standard form. This is where I would expect you to end up. And you would tell me that your A value is 3, your B value is 80, and your C value is 150. Not too complicated, but again, make sure you ask if you have any questions on it. So you're going to have the ability to take something that may not be in standard form and put it into standard form for me. We have, I think, one more topic to talk about in here, and that's the idea of intercepts. Think back to your Algebra 1 class and what you might already know about intercepts, and try to formulate an idea of what we might write in our notebooks about that. An intercept is a point or points associated with the function where the graph crosses or touches the axis. It's kind of bad handwriting there. We have two types of intercepts. We have an x-intercept. And if that's where the graph touches or crosses the x-axis, let me draw you a quick little coordinate plane over here. If this is our x-axis, this is our y-axis, an x-intercept would be any point that touches or crosses along this axis line. So something right here, and the graph can either pass through it or just touch and turn. Every coordinate here deals with, or every point here deals with an x-axis value, but no y-axis value. So we say that for an x-intercept, y is equal to 0. Basically, it fits the form x comma 0. For the y-intercept, we're going to say that that's going to touch on the y-axis somewhere along that axis line. So we'll say that the x is equal to 0, and therefore holds the form of an ordered pair of 0 comma y. The y-intercept in your slope intercept form in y equals mx plus b is the value of b. I'm going to ask that you write them as points, so x comma 0, 0 comma y in that kind of format. If you have a function, can you have more than one y-intercept? That's a question that I'm going to pose to you and I want you to think about, and we're going to talk about together when you come into class next. Can a function have more than one y-intercept? Okay, the last example that I have for us to do is this. Find the x and y-intercepts of 2x minus 3y plus 8 equals 0. So we can do this a couple ways. We could go through and graph this and check out what's going on, but we may not, at this level of math, always end up with really nice values, and we might end up with fractions and decimals for intercepts, and it might be hard to figure out graphically, at least longhand. I can show you when you get into class how to do this on your calculator, and it may be a little bit easier, but we're going to focus on the algebraic approach of it. So my x-intercept, just erase this here, my x-intercept or intercepts, we'll find out how many we have, if it's even possible to have more than one x-intercept, is when y equals 0. So I'm going to take my function 2x minus 3y plus 8 equals 0. And if I put 0 in for y here, this entire term goes away. So it's kind of like I cover up the term that has y, and I'm left with 2x plus 8 equals 0, 2x equals negative 8, and x will be equal to negative 4. So this is telling me that the graph hits, either touches or crosses through the x-axis at the point negative 4, 0. The y-intercept, on the other hand, remember, is when x is equal to 0. So I'm going to take the same equation, 2x minus 3y plus 8 equal to 0, and this time we're going to make the x value equal to 0. And if I do that, that knocks out the entire x term, and we're left with the equation negative 3y plus 8 equals 0. If I solve that, I'll have negative 3y equals negative 8, and y will be equal to 8/3. So this graph is crossing at 0.08/3. If we take these 2 points into account here as our intercepts, negative 4, 0, and 0.08/3, and you're asked to actually graph your function, because I do extend this a little bit and ask you to graph. Remember, if this is a line and it is a linear function, in order to graph, you just need 2 points. So I'm going to erase this here, and we're going to graph our function. Because we have our intercepts, it's going to be pretty simple. We've got to just go along the x-axis. We had an x-intercept of negative 4, 0, and a y-intercept of 0.08/3. 8/3 is about 2 2/3, so I'm going to put my dot over here. And then, because this is linear, I'm just going to connect them. And this is the equation, the graph of the equation 2x minus 3y plus 8 equals 0. So at this point, graphing is strictly finding your points and connecting your dots, even though I know you guys have more advanced ability in order to do that. So this kind of wraps up section 2.2. Let me know if you have any questions. We can tackle those in class, or shoot me an email and I can give you an answer before you get into class. But I will see you next time. Thanks for listening.